As far as pre-bound and rebound, when you do demand response right now, if you know you've got, as a facility, you're going to sit there and hit the chillers or hit the heat or alter process. Well, when you do it, sometimes you get a pre-bound effect where you load up before, and then after the event takes place, you'll load up again. When you use the DG to get the job done, or the IDG, there's no pre-bound or rebound. You just soft load, soft unload later. So it's very nice for the utility system as well as the facility, pre-bounding, rebounding, and changing operations to get this done. Here's a typical turnkey operation. Utility goes into the facility. What do? You place in switchgear that's got 2 circuit breakers on it, some protection, and the brains to get the job done. Talk about that in a minute. You could do greenfield and retrofit. New facility, the one on the lower right, that would be retrofitting in. You have a transfer switch, you retrofit in the 2 circuit breakers. Why do you do that? It makes it seamless. You can close, synchronize, load up, then unload, go away. Nobody even knows it happened. Here's some more retrofit applications, and of course you can always have more generators and more circuit breakers. We're just keeping it simple. 1 with 2 breakers gets the point across. When we peel the onion a little bit away, what do we have? Communications for the dispatch and the monitoring. Utility protection, because the utilities don't like you to parallel with them unless you do certain things. It's called IEEE 1547. It's a standard. If you do all that, the utilities are cool with it. Well, they all have their rules too, but it's based on 1547. You have system control and HMI, then the generator protection metering, and finally the engine generator. When we go and look at this, here's an outdoor system. It's an ANEMA 3 cabinet. You're all set up to be placed outdoors. We actually removed a transfer switch, literally, like the crane came in, we disconnected the wires first, pulled it out, and put this right in. Here's an indoor one. We took out a bunch of old gear that couldn't parallel, put it in that can. So indoor or outdoor doesn't make a difference, the amount of generators doesn't make a difference, but just so you can get a look and a feel, this is what these systems look like. Protective relaying the utility wants, the right brains and the right muscle, which is the circuit breakers, and also a little bit of brain for the generator. Most generators, when they come out and they sit behind a building, they know how to run it like 60 hertz and at rated voltage. They don't know how to run in parallel with the utility. They need a brain upgrade. So we make sure we put a brain upgrade in, we put in better control to get the job done. If we look at the block diagram on the right, you can kind of see the way the information flows. From the bottom is the field assets, which would be the circuit breakers and the generators. You go into protective relays and generator controls, which are separate because that's good philosophy. Control and protection are separated. An HMI, the HMI acts as the buffer to the internet. We use a lot of GE equipment for that as far as the HMI and some PLC control. And then we use great majority public IP to get the transmission of the information across and whether to start or run and for the maintenance. As far as protection, key thing is 1547. If you're a facility and you want to do this, the utility, the first words out of the interconnect guys, vocabulary, are you 1547 compliant and have you read our interconnect agreement? So being at 1547 is a great way to start the day, and that makes it quote unquote utility grade. When you look at the control, and you'll see we have some dotted lines that show the interface from SCADA through the HMI. There's the SCADA interface itself, and then there's monitoring, starting and stopping, governor and regulator control. You have to be able to tell the generator at what speed and what load to assume, and what VAR or voltage to put out. So that's what's being shown across the bottom with the communication, but it's collected from the HMI and the PLC, and then that shoots out global commands, and we'll show you those. The role of remote operations and management. Dispatch, be able to quickly dispatch individual or aggregated units as a collection. Utilities will want to aggregate ones in their territory, much like Florida Power and Light did when they had the incident. Monitoring, operational status, are you running or not? Select metering from the utility and the facility so we can see what's going on. You monitor exception alarms. There's hundreds of alarms that are monitored, but that would be data choke, right? You got thousands of these machines all over the place and it'd be data choke. If you monitor for key alarms that are in grouped master alarms, then you could peel the onion back when you need to. We'll show you a few of those. And then you'd be able to drill down. So one of the ways we handle a data choke on these very small assets is to do master alarming and then only certain types of control to get going. Here's a kind of a block diagram of it. On the right-hand side, we have the utility. They give a load reduction command. Out goes the command on IP to all the assets. TVA wanted to do this 25 years ago. They said it would be like $50,000 at each little location where the generator cost $80,000. Oh, it didn't make much sense. Now with public IP and the cost reduction that's taken place in protection control, HMIs, and monitoring, you're able to do this and make a recoup in anywhere from 2 to 4 years, depending on your demand rate, so it can get attractive. As we look on the left-hand side, there's the IDG at the C&I facilities. That's you folks, and you start her up and you run her at those key times. The dispatch types, what do you got? Off, auto, you can run the engine or put the system online. When the system's in the automated mode, emergency power. That's why most of the iron's on the ground, right? The ice storm hits, the hurricane hits, the flood takes place, drunk hits pole, pole falls down. We need to get the power. So first and foremost, emergency power. But then the dispatch is load management and proactive isolation. Think of this, I live in Florida also where this conference is. The hurricane's coming in, the wind's picking up to 50 miles an hour. Would I like to take this facility off the grid without a blip? Now, this isn't a critical process facility. Would I like to take your wafer plant off without a blip when I know the ice storm is coming before the lines fall down and you get conductor galloping in the wind and all that other great stuff that takes place on utility systems? Here's your autonomous emergency power. The blue line's the utility, the red line's the generator. It's not to scale, but there's a gap. You get a blip because nobody can predict when an outage takes place. It does, things start, things run. Here's your demand response, and you'll notice the crisscrossing of the lines right here. Your utility demand goes down, the facility gets self-powered from the generator, and that could be like this case where you're almost powering the complete load, or this case where you're actually exporting. That's on agreement with your utility, but it can be done. And then finally, you have the isolation mode, the hurricane's coming, where you take the utility power down, but really what takes it down is you bring the generator up, disconnect, run on your own, and then come back bliplessly or bumplessly later. As far as batching, there's a couple of ways to command these. A status batch, you want to test these things. We go out and we'll test for the XYZ supermarket chain when we have 500 of these installed. We'll do blocks of 20 every hour. We run them for an hour, record data. If there's no exception, you move on to the next one. By doing that, you eliminate manual load testing, and you also make sure through automation, right, through the communications, the remote operations and management, that you're getting this testing done, and guess what? No personnel had to be there to get the job done. It was done completely automated. There's schedule batching, and that's for load testing, load control, start and stop, and that's per utility agreement, and start batching. So there's different ways to go and aggregate the way you start these things and the way not. You know, think of this, if you only had one, it's easy. When you got like thousands, it gets harder. And even for a given utility that may have hundreds in their operating territory, how do you go and handle these? So you don't want to sit there and say, well, gee, we got a demand response incident, let's start flipping the switches one at a time. You make predetermined in geographic areas where the load management needs to be done, and you aggregate. So a key word here is doing the aggregation. When we look at a global metering and monitoring screen, we're able to see the status of the two circuit breakers, which one's closed, is it the utility one, or is it the generator one, or is it both? And you're able to see, you know, bird's eye snapshot. What's the volts and amps per phase? And you're able to see the beginning of the master alarm list. If everything's fine, that's as far as you have to look. You can drill down further and get much more operational data, status of the switches, and of course you make a nice HMI and you're able to go and see this. This could be local on the device as well as at the head end where you're doing this bulk aggregation and getting the monitoring done. Here you're getting much more detail in the alarms. Now when you look at demand profile, here's what you're trying to whack out. As the hourly demand profile changes, if you're getting billed on what's called coincident peak, where they look at the highest thing you did in 15 minutes for 30 days, if you can nail that peak and you take that off, you save tons. That critical peak pricing and what they call coincident peak, CP, in utility vernacular for your billing is a heavy hit. Here's detailed alarms. So I'm not going to read all these, you know. You have master alarms, then you have your detail alarms. So to go and sum this up, what you're basically doing is aggregating the dispatch, and then you're looking at master alarms, which have easy throughput to get through, and if you have a couple of ones that are in trouble, you can drill down and get as deep as you want to go. We've actually told facilities when they've had an outage and they've gone on emergency power that the utility transformer blew a fuse on the high side. I mean, we were able to actually call the utility and say, roll a truck. That's the kind of, you know, if you want to get into remote operations management, this is what this offers. So here's my summary. Interactive distributed generation can be used for demand response, and that's for the utility as well as the facility. It's a two-way street. If there's no utility rate and rate reduction and incentive, why do it? If there is one there, everybody gets to play. And you get to play when you're a 24/7 facility where you don't have discretionary load or much discretionary load and wish you could play more in the demand response arena. Well, here's the way to do it. IDG using remote operations management allows the utility dispatch. That makes them happy and gives you the incentive. You make sure that the assets are monitored, including load testing without rolling out banks and people, which helps the economic equation and the reliability equation get even better. The ROM can be optimized so control is limited to a few global commands. We're not sending out run at this megawatts and run at that VAR. We're sending out run, do load management, do an isolation, that's it. So it's easy commands out, it's really fast, and it makes the case for putting, it's a distributed intelligence. A lot of intelligence is inside the switchgear. The communications that actually, goes through the pipe, unless there's an anomaly, is slim. There's really not a lot there. It's like, don't run, look at some key alarms, we're done, or do a test, and that's it. So it's nice and light due to the distributed intelligence of the application. That's it.